said they didn't get the link. I don't understand. I didn't send any link in the chat box. Um, yeah, some students answered my question during the class, but I didn't send any link. So I don't quite understand your question. But I have sent one link before about attendance, but we don't need it now because I can download your attendance form in this app.
Ma'am, we are actually talking about that link. I mean, attendance link. We didn't get it. I mean, we are
okay. And in the previous class, we left one question about how to add the four vectors. First, we can say, in order to add the four vectors graphically, we put the four vectors one by one. Yes, P equals P1 and P2 and P3 and P4. First, we need to put the four vectors one by one. The head of the origin of P2 is uh, is in the same direction of the head of P1, and the head of P2 is in the same direction of P3. The head of P3, the head of P3, the origin of P4. By drawing this, drawing the two vectors in this direction, we can have one arrow from the origin of P1 to the head of P4. And this is the addition of the four vectors. I hope you can understand this vector addition graphically. This is the vector addition is very, very important. If you don't understand the vector addition, you will not know anything about college physics in the whole semester. So this is very, very important. You must know it. Everyone should know it. Okay, after addition, we have multiply. How to multiply a vector by a vector? This is a bit more difficult than addition. We call the vector multiply the dot product. A vector multiply a vector equals a scalar. Here we have the same two vectors, vector A and vector B. Vector A dot multiply vector B, or we can also say vector A dot vector B equals a scalar C. And it equals the magnitude of vector A multiply the magnitude of vector B and dot cosine theta. Theta is the angle between vector A and vector B. Here we have um, okay, some students said I just said there is no link at all. Some students say text in the WeChat group, but we didn't have any link. So do not ask for the link, okay? We didn't have any link.
Link means attendance link, man. Maybe you have.
Okay, the dot product of the unit vectors equals what? If the two vectors have the same direction, the theta equals what? Equals 0, right? If theta equals 0, cosine theta equals 1. So we have unit vector I dot unit vector I equals 1. And we also have the multiplying of unit vector j and the unit vector j equals 1. And unit vector k dot itself equals 1. And for what about the unit vector I dot unit vector j? What if unit vector I equals dot unit vector j? We know in a coordinate system, yes, we know in a coordinate system, the unit vectors ijk are perpendicular to each other. So the theta equals pi over 2, right? Cosine pi over 2 equals 0. So we have unit vector I dot unit vector j equals 0. So for the dot product, we can also use it in the coordinate system. The dot product of vector A and vector B equals C, and it equals ax bx and ay by and az bz. And the magnitude of a vector A equals root vector A dot vector A. Okay, and just now we have the dot product, and then we have the cross product. Maybe you have knowing the cross product in your um, math course or some other courses related to math and physics and mechanics. The cross product is also uh, an important part in vector multiplying. We use this symbol, cross, right? This is very um, implying A cross B equals a vector C. And the cross product has directions. A cross B equals C, but if we have B cross C, it equals minus C. So it has directions. In order to know the calculation of cross product, we need to know about linear algebra first. During your previous courses, I think everyone have known about linear algebra, right? In your math project. Yes, you have known, you have taken the college math courses. So we use this equation to calculate the cross product. Okay, you are learning. So this equation is a little bit more difficult than the previous one. Uh, you, in each component, you have two. Yes, in each component, you have two components. For the, let me see. Okay, let's see how to calculate this. Here, for the I component, for the X component, we have the cross product. We have cross, right? This word cross. So we need to cross it. First, AY and BZ. Here, cross AYBZ minus AZBY. This means cross. Yes. AYBZ minus AZBY is the first component in the x direction. And then we have J. To calculate the component in J, you need to cross this cross and AZBX minus AXBZ. Here, this cross. And for the K component, we have first cross this 9 and this 9. And then doing the calculation by crossing AX BY minus AY BX. Okay, this is the calculation of the vector or cross product. And we can also use this equation to calculate the magnitude of vector c. The magnitude of vector c equals the magnitude of vector a and b sine alpha. Alpha is the uh, uh, angle between vector A and vector B. And the direction is determined by right-hand rule. Here, the direction is determined by the right-hand rule. First, you need to put up your right hand. Then, first your four fingers. You have a thumb and four fingers. Your four fingers point to the direction of the first vector A. And then your four fingers squeeze to the direction of the second. Yes, your fingers squeeze to the direction of the second vector. Squares to the direction of the second vector. And now the direction of your thumb is the direction of the cross product. Let me repeat it. In order to define the direction of the cross product, you need to first put up your right hand. You have a thumb and four fingers. First, put your fingers towards the direction of the first vector. And then your thumbs, the forefinger squeeze to the direction of the second vector. And then the direction of your thumb is the direction of the cross product. Okay, from the right-hand rule, we can know one important thing. We can see your right hand, the thumb, and the four fingers are always perpendicular to each other, which means the vector cross product vector is always perpendicular to the two vectors. C is always perpendicular to A and B. And we can do it again. If the first vector is B and B cross A, we can use our right hand. First, our four fingers put, uh, raise up our right hand. Our four fingers point to the direction of vector B, and then our four fingers squeeze towards the direction of vector A. And then we have the direction of the cross product, which equals minus C. Okay, here we come to the second part of our class, description of motion. Having known the basic concepts of vector addition, vector multiplying, now we come to absoluteness and relativity of motion. The world and everything in it moves. Even semi-stationary things such as the house moves with the earth. The earth's orbit around the sun, the sun's orbit around the center of the Milky Way galaxy, and that galaxy's migration relative to other galaxies. So, we can say that there is no stationary thing in the whole universe. There is no absolutely static object. In order to describe the position of an object, the other objects referred to should be chosen, and we call it reference frame. And the reference frame, or we can also say frame of reference, is arbitrary. And we can also see the reference frame is really important when we describe the motion of one object. So the description of motion depends on the frame of reference. And we see this rule, the relativity of motion. we can uh, we can see this as an example. Um, the speed of the velocity of the dog is dependent on the frame of reference chosen. Let's think if we choose the tree as the frame of reference, we can see the dog is moving towards the x direction in a relatively small speed. But if we choose the car as a frame of reference, what uh, what can we how can we describe the motion of the dog? How will you describe the motion of the dog if you choose the car as the frame of reference? How will you describe the motion of the dog if you choose the car as the frame of reference? Okay, let me repeat my question. One student just attended the class because of failure in the network. Okay, let me repeat my question. Um, what will you describe the motion of the dog if you choose the car and the frame of reference? I will give you a hint. Um, the we assume the right side, the x is pointing towards the right direction. A, let me see. Is every any other answers? One student said, as both are moving, one will look another and standing. Okay, let's see from the picture. Okay, another student is typing personally to me. Uh, she says, or I don't know she or he. This student said, car says dog is walking backward. Car says dog is walking backward. Any other suggestion? Any other answer? Yes, they don't have the same velocity. Okay, okay, yes, both are, one student said, both are looking moving. Yes, yes, everyone has their own opinion. In most circumstances, in most cases, we will uh, choose the object that seems stationary to us as the frame of reference, right? So in most cases, we choose the ground or the tree as the frame of reference. If we choose the ground or the tree as the frame of reference, the dog is moving forward. But in some circumstances, we choose the car as the frame of reference. So if we are standing in the car, we can see that the dog has a relatively lower speed. So the car, the um, dog is walking backward. So this student, uh, Janani, yes, Janani's answer is right. And we will also say, yes, DIP's answer is right. Yes. So many students have the right answer. And the first student says as both are moving, one will look another and standing. Uh, yes, they are both moving, but they have they have different velocity. They have different speed. So if they don't have the same speed, it will not look standing. Okay, from this question, from this example, we can say the choice of reference frame is really important, and it can really influence our way of description of motion. So frame of reference is really important to us. And after choosing the frame of reference, we can introduce you um, the coordinate system. A coordinate system is used to determine the location of a body and the reference object quantitatively. And a coordinate system is built on it. So we from this sentence we can know first you need to choose a frame of reference. Then you build a coordinate system on it. So coordinate system is a math conception attached to the real world bodies. We can choose the coordinate choose a reference frame like a car, a building, or other things, and build a coordinate system on it. Uh, the the most ordinary coordinate system we used is a rectangular coordinate system, or we can also call it Cartesian system, because this Cartesian is a scientist's name that proposed this coordinate system. So from this, we know that it is very important for you to work really hard and propose some important things to get your name influenced, get your name to the leave your name to others, right? Look, Cartesian have proposed this system, so he left his name to us. I think everyone knows about math and physics, knows about Cartesian. Okay, Cartesian system is a rectangular coordinate system. IJK, yes, it has three axes, x, y, z, and the corresponding unit vectors. Unit vectors are IJK. And from previously vector multiplying methods, we can know I cross j equals k, right? We can use the right hand rule to determine the whether it's right. First, we put up our right hand. We put our four fingers towards the first vector j, and then we put our four fingers towards the second unit vector j, and then the our thumb is in the same direction with the vector k. So this is right. And we can also prove the remaining equations. And we also have the origin. Oh, origin is the uh, origin of the three vectors. Except for the besides the rectangular coordinate system, we have another coordinate, natural coordinate. We use two vectors, et and en, and o to represent the vector, every point on this coordinate. Et is a tangential unit vector on this point, and En is a normal vector on this point. In the future, we may face this natural coordinate system. Okay, that's all to today's class. In this class, we have known the. Let's take a brief review. Yes. In this vector, in this class, we learned about scalar and vector. Definition of the scalar and the definition of the vector. And then we learned about handwriting of the vector and how to divide a vector into components. By dividing the vector into components, we can calculate the magnitude of the vector and many other parameters. And we learned about vector addition in two ways. Adding vectors by components and graphically. There are two ways to add the vectors graphically. And then we learned about how to multiply two vectors. There are two ways to multiply vectors. The first way is to dot the vectors. The second way is to cross the vectors. And we learned some basic concepts of motion. The most important thing to describe the motion is the choice of reference frame. And after learning about the reference frame, we introduced the coordinate system, and we have two coordinate systems, rectangular coordinate system and natural coordinate system. Okay, that's all for today's class. See you next week.